So let me take out the same example as given in lead code. I will take this one. So let me put it here and I will break it down into individual characters for this input string, like I and I will calculate DPI using the bottom-up approach here. Okay, so we'll start with the last. So as we have done with the previous bottom-up approach, that we start with the base case and then we move up to the higher cases and try to see whether we can reuse the solutions of the sub-problems that we have already solved. Or we can also have any pattern or algorithm which can be used. So I'll start with the last index, starting from the last index 6. We will keep on moving until we find the final solution at dp of 0. So let's start with dp of 2, our first base case, which is this one. So if we are given just with like one individual digit, only 6, so it means that there is only like one way where we can decode it into the letter that is mapped to it. Because as you remember, right, that the whole idea is that it starts from A, B until Z. And each of them starts with 1, 2, and all, right, until 26. Maybe I'll just put it here so we get enough space. So I will just write down some special cases. For example, A, B, C, D, it will all keep on going until we reach to 10th, right? 10th, and then so if we have only one digit available, so we can see that if we have only like one digit, it's possible to have from 1 to 9. It cannot, only one digit which is not possible, which is not correct, is 0, right? 0 can, if there's a 0 there, it means that it's not going to map with any value, with any letter to be decoded. So if we are checking only for one individual in one number or a digit, just for example 6, 2, and all, it will all be valid if it falls in the range from 1 to 9. Only when it's 0, then the number of ways would be 0. So this is our base case here. So in this scenario, as we have seen that if the number is 6, it means that the number of ways to decode it was only 1, because 6 is a valid number, and it would be decoded to a correct letter. So here the dp2 for only using just 6 is 1. So I'll put it as 1 here. Now let's go to dp1, which is taking these 2 and 6 together, if we are given with these two digits. So for these two digits, right? So we have to first check only like one digit here, which is 2. Again, we check that if 2 is within the range 1 to 9, right? Because if we are just treating one particular digit, only 1, 2 here, in that case we just have to check for single digit, it should be in the range from 1 to 9. Only when it's 0, only in that case it would be the number of ways to decode would be 0, as we have checked in the previous base case. So here also is code switch same. So we just treat only like one digit here, and we found that it's already between 1 to 9. So this 2 is valid. So it means that if we just go through each and both 6, this is like one way, and if we go to 2, it would be still the same way, right? So it means that we can come up with this formula that the very base case for each of the individual digit would be that if I go only with this, so it would be the continuation of, so dp of I, which is dp of 1, would be starting with at least I plus 1, right? because whatever the number of ways was there, it would be still continuation with the same way. Both 6 and 2, that counts to one way. We can decode it's like with 6, A, B, C, D, E, F, A, B, C, D, E, F, G. So this would be G, and this would be B. So B and G, this counts only like one way. That's why we are treating that DP of 1 would be the next, starting with the base case is that it would be DP plus 1. Now we have got 1, so DP of I plus 1 is already 2. So we start with first case, that we have got a base case that we just take these two individual letters, these two individual digits, and this is one way. Now we check with both the words together. Now suppose, if this was 0, right? So for example, 6, it was 0, and then it would be the DP of 2 would have been 0 then, right? So it means that if I take 0 and 2, then just taking 2 will not make any sense, because it will not count to any letters to be decoded. So that's why in that case, our base case for deep is like 2 and 0. So there would be only like one base case. So we cannot treat like 0, because 0 doesn't map to anything. We cannot just have like individual characters as 0 and then 2 separately. No, it's not possible. If one letter is missing, then in that case, the whole DP would be 0 for that. There will be no ways to decode it. Only when we treat both 2 and 0, 20, only in that case, it will form one case, for which we'll check the next, right? So that's why, whenever we see 0 anywhere, we simply mark that DP as 0 for that case, because 0 doesn't stands alone. It cannot form like any way to decode it. It can only come as 10 or 20 only when we are treating 2 digits at a time. If we are treating 1 digit at a time, whenever we see 0, we'll mark it as 0. So these are two other base cases. Now let's, as we have considered like individual letters, digits first. Now let's take both 2 and 6 together. When we are treating this 2 and 6 together, right, we know that at this, the tens unit, it can be only 1 or only 2, right? So if it's say against 0 or 3 or whatever, in all those scenarios, it would be the number of decode ways would be 0. It cannot be 0 if you're treating these two letters together, or it cannot be anything other than 1 or 2. If it's like 3, 4, 5, whatever, in that case, it would all be resulting in 0 number of ways to decode it. So only valid range is that it should be 1 or 2 here in this case. Sorry, it should be 1, 2. Okay. And once we have this 1, 2, again, if it's 1, for example, it's only like 1, then this number at the ones unit, it can be 0 to 9, right? Because the range is from 10 to 19. So once we have got this as 1, then in that case, it's possible to have this digit, whatever is like 0 or 0 to 9, whatever is there, it will all be valid, and it will be counted as one count of decoding ways. And if it's 2, then in that case, because it's from 20 to 26, so here it can be 0 to 6, right? If it's 7, 8, 9, then in those scenarios, it will be counting as 0. There will be no weight. So we have to like check these two conditions, that whether it's 1 or 2. If it's 1, then in that case, it would be the ones unit can be 0 to 9. If it's 2, it can be only between 0 to 6. If any digit other than 1 or 2, it will all be resulting in 0. So in this scenario, we already see that 26 is another way. So in that case, we have already checked that it would be another. So it would be 1 plus 1. 1 was we already calculated when we treat each individual digits. So we already found that DPI is equal to DPI 1. And then when we treated all 2 and 6 together, and it's within the range, it's starting with 2. And the ones unit, it's between 0 to 6. So that's why there is another way. So total is 1 plus 1, which is 2. So this is our dp for 1. So I'll just mark it as 2, and this is 2.